Is there any such thing as fiction in the multiverse? The multiverse is an attempt by physicists to explain some of the inherent weirdness associated with quantum mechanics and the probabilistic nature of subatomic particles. It turns out there are several alternative versions of the multiverse, and I'm going to assume the many worlds interpretation for the purposes of this thought experiment. The many worlds interpretation postulates that literally every possible quantum outcome is realised, and the universe splits into many universes continuously, resulting in an infinite number of universes. If this sounds a bit mad, all I can say is that during several surveys, many, in some cases more than half of physicists, believe some version of the multiverse hypothesis to be correct. Probably partly because the alternative double-slit wave-particle strangeness, which the multiverse obviates, is also a bit mad. Anyway, background over. Let's try and answer the exam question. What does multiverse mean for fiction? Starting with some basic fictional scenarios, any storyline that is grounded in normal reality will be non-fiction in some universe. In fact, with an infinite number of universes, there will be an infinite number of these, the weird math of infinity. It is not difficult to imagine any number of minor changes in past events rippling through time and resulting in a different version of the present reality that mirrors what we consider to be fiction. So far so good. None of this sounds in any way unreasonable, assuming you accept one or other versions of multiverse hypothesis, and it's not much of a stretch to imagine some completely plausible past scenarios that could change history as we know it. The further back in time the divergent event occurs, the greater the potential change. But what about all the fiction that apparently breaks the laws of physics? That can't be non-fiction, right? Well, actually, yes, it can if the multiverse considered is truly infinite and you factor in previously mentioned wacky world of quantum mechanics. Full disclosure at this point, if it's not already apparent, I'm not a physicist and far too dumb and old to be one. Having said that, here's some very basic math associated with something referred to as the Heisenberg uncertainty principle, which is at the very core of this whole thing. According to the uncertainty principle, it is not possible to exactly measure both the position and momentum of any subatomic particle, and in fact the position is described by an equation that generates a probability based on the distance from the atomic nucleus. To illustrate this, here's the equation for the position of an electron in the most simple atom, hydrogen, in its most simple or ground state. You plug some numbers into this equation, you get a curve that looks like this. Probability is on the y-axis and distance is on the x-axis. Now imagine a fuzzy donut shape surrounding a tiny central point. The key thing here is that although the line appears to go to zero a short distance away from the nucleus, it never actually does, however far away you look. If you plot the same curve using a logarithmic y-axis, you can see this illustrated more clearly. Now, Excel limits how small you can do these calculations. You can see that the probability is ridiculously small, even at very small distance. However, once again, it is not zero. For fun, and using some quick and dirty math, let's see roughly what the probability is that some universe somewhere, an apple apparently disobeys the laws of physics and instantaneously disappears and reappears 1 metre away from its previous position. There's quite a lot of subatomic particles in an apple, so for the said event to happen, there's quite a lot of improbable events all occurring simultaneously. Plus, I have no idea how to even roughly calculate the likelihood they would all move in the same direction. Suffice to say, it's a very, very, very small number, but not zero. And infinity is a very big number or concept. If you don't believe me, which would be very sensible, ChatGPT agrees, and I'm sure it knows much more than I do. Using this same logic, let's look at some apparently physics-defying things in fiction and see if they can actually be a real thing somewhere in a multiverse. Magical appearances we've more or less covered using the Apple scenario, but with the slight potential difference that rather than moving an object from one place to another, let's go with stealing subatomic particles from elsewhere and conveniently assembling them into the precise configuration of the object in question. Oh, and let's also add the coincidence, however this is calculated, that a particular set of magic words or gestures always produces the same madly improbable set of outcomes. Once again, improbable, but entirely non-fictional in some version of another universe. What about anti-gravity or levitation? Well, same logic, although with a much higher probability of this happening at least once, since the distance would be tiny, but then compounded with this happening continuously. So, once again, non-fiction. faster than light travel. Same logic, but applied over a much greater distance and continuously. Time travel. Well, this is trickier, but also potentially possible if you scale the thought experiment up and assume that rather than moving backwards or forwards in time, the time traveller essentially doesn't go anywhere and the rest of the universe spontaneously reconfigures itself into a different state corresponding to the different time period. So, once again, non-fiction. This same logic can be used to explain more or less anything that is described in fiction, with the possible exception of quantum entanglement events, once again crashing my head against my very limited knowledge of physics. So, is there any such thing as fiction in a multiverse? Maybe.